Okay, so today's problem, we're going to do it on volume. So if you haven't had volume, then you can probably learn a lot from just the beginning, and we're going to start from just the basic line segment. Okay, so a volume is something that has to do with dimensions. And maybe you've heard that before. Someone came from another dimension, aliens from another dimension, or something like that. Well, volume is 3D, but we're going to start at 1D. And I know you guys have dealt with 1D before because that is the number line. Right? -1, -2, and so on. So there's a number line, and a 1D object is just a line, and it's L long. It's some number long. We could call it 1. It's 1 unit long. And we're going to say that that is L. It's 1 long. Okay? Then we can go to 2D. 2D is a square. And that's just like taking two line segments and having them be crossing with 90 degrees. Okay, so we have one line or one side and another side. And we might say that those sides are equal to 1 each. And so then their area, or the inside part, the area, is equal to 1 times 1. Okay, the side times the side, multiplying. Then we go to 3D. 3D is the third dimension, and that's what volume is. Here we found area in 2D, we found length in 1D, and now we're going to find volume in 3D. Volume, area, length. Okay, and then, so I'm just going to draw a cube here. And volume is this length times this height times this width. Okay, and we call that length times height times width. Okay, and we'd say that this is our length, this is our height, and this is our width. Okay, and so in all these cases, it's 1, but they're in different dimensions. We have a line that is equal to 1 in one dimension. We have an area, S times S, that is equal to 1 in 2D, and we have a volume, 1 times 1 times 1, that is equal to 1 in 3D. So that is going to help us solve these problems for volume. So now, if you think you get it, then go ahead and pause the video, and you can go and solve these problems, and then when you restart the video, you can watch me solve it. So I'm going to solve it now. This is a cube. It says that all our cubes are, or all our lengths are centimeters, or they're centimeter cubes. So this is a 1 centimeter, 1 centimeter, and a 1 centimeter. For this length, and this one, and this one, that gives me all 3 directions. And that's just 1 times 1 times 1 equals 1 for A. That's answer A. For B, well, if we might have already realized that we could actually just find this, and that's 1, so we could just count 1, 2, 3, 4, 5. But let's prove that. Let's do our length times height times width formula. Let's go and split this up into one block by itself, which is 1 times 1 times 1. So this one's just equal to 1, this block by itself. And then we have these 4 left over, which is 1 unit, 2 units, and then we go up 1 unit, 2 units, and we go backwards 1 unit. And so volume is length times height times width, length times height times width, which is 2 times 2 times 1, which is 4. And then this 1 that I was adding it to was from this other cube that we did first, which gives us 5, which is what we counted. 1, 2, 3, 4, 5. 5 cubes of volume 1 is just 5. So here, we could probably do the same. Try and count 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait a minute. But there's stuff I can't see in the back. So maybe 9 isn't right. Let's test it. Let's see if this is equal to the volume. So we have 2, 2, and we have 2. 1, 2, 1, 2, 1, 2, right? Across, up, and back. 2 times 2 times 2 is equal to 8. So I counted wrong. That was wrong. The volume is 8 because we trusted our formula and we know that it's length times height times width. Okay, last problem. So I'll let you guys do this on your own. Oh, actually you did do it on your own, huh? So I'm solving it for you. So our length is 1, 2, 3, 4, 5. And our height is 1, 2, 3, 4, 5. And our width is 1, 2, 3, 4, 5. 5 times 5 times 5 equals 125. Okay, that's your answer.